Welcome to a structural analysis video from the Ultralight Airplane Workshop. I'm Leon. This is a continuation of a series I started on designing a truss-style rib for the Univis 4 ultralight airplane. And by the way, when I say ultralight airplane, I mean an airplane that meets the Federal Aviation Regulation Part 103 here in the United States. Now, if I remember right, this is Part B of this current series. There was a previous series where I designed a cantilever-style rib. And that's this rib here. We tested it almost to destruction. I didn't quite have enough weight to go ahead and destroy it, but it certainly went up to be permanently deformed. A few bends around here. And that's with a 517-pound gross weight for the ultralight, 3.8 Gs plus 1.5 safety factor. So this went up to a load of about 112 pounds, if I remember correctly. So it actually worked pretty well, given that I didn't do any true design on it. I didn't do any analysis to figure out what I had to do for thickness of this web in here, for example. Now, I had done some tests on individual pieces to figure out what this radius should be in here. So I kind of knew what that needed to be, and I knew what this flange had to be in here. But other than that, I just took a guess at how the rest of it should be. And it turned out pretty well. I'm surprised. Now, after I went to AirVenture 2023, actually during AirVenture 2023, I decided to increase the gross weight of the airplane. It went up to, I think, 580 pounds gross weight, maximum gross weight. This rib probably would not be able to handle it. I mean, it's already deformed at 517 pounds gross weight. Another 10%, it may not have been able to handle it. Now, I had already intended to test a truss-style rib. By the way, when I say truss-style, let me bring up a drawing here. It's something like this. This is the same nose rib. Actually, it's not quite the same. The airfoil changed just a little bit. But as you can see, there are cross members in here, which makes it a truss style, whereas the cantilever did not have those. These are templates for cutting out aluminum. That's this template on your left. This one over here is for forming the aluminum, because it's going to have flanges. We'll use this to form the flanges over here on your right. But as I was designing this, I thought I might actually have a little more surface area on this truss-style rib than on the cantilever, making it heavier. Now, this cantilever was 72.5 grams, if I remember correctly. It'll be interesting to see how light or heavy this truss style is when we get it done. So in this video, we're going to cut out these forms, and we're going to cut out some aluminum using the template form. In the next video, work on the bending form. So my plan is to cut out this template. Now, this is going to be the template for cutting out the aluminum, just like I did here for the cantilever style. And then this will be the template for cutting out the form that I'll form the aluminum over. But before I do this cutout, I wanted to lay out the old cutout on here and kind of get an idea of how much aluminum I have compared to the cantilever. And it's kind of hard to tell. I kind of think it's going to be very close to the same. Oh, and by the way, this nose is different on the newer form. I've changed it a little bit. I've made it more round. So it's not quite in the same place as it was when we did the cantilever. It's a slightly different airfoil, but overall it's pretty close. This one here was the UAK-01. This is the UAK-02. Not because of the truss style, but because I changed the airfoil shape just a little bit. So my plan is to cut this out. I will then glue it to a piece of board, same thing on this side. And then I will cut the shapes out. Now on the outer shape, I'll use a bandsaw and a disc sander to get them down to the correct size. I'll actually drill these holes out with a drill first. And then I'm going to cut the inside. And I think the way I'm going to do that is first I'm going to drill these little spots out here. Now, I said I made these 0.4 inches radius, so it'd be 0.8 inches diameter. Now, I don't have anything that's actually 0.8 inches. What I may do instead is use 3/4 diameter. So that will leave me 50 thousandths, a little bit too small. That's not bad at all. So that'd be 25 thousandths too small for radius. That's pretty darn close. I can go with that. And then I can use a straight edge to run a router along these straight edges. That was one of the reasons I made these straight instead of rounded. It's much easier to take them out using a router and a straight edge. Same thing over here. And then I'll have to just do a little bit of trimming right in this area. So I'm going to cut these out so I don't have a lot of excess paper hanging out all my wood. Now I do have another copy of this, so it doesn't really matter if I lose my dimensions that I've got on here. Well, I just happen to have this board. It's almost perfect. Just barely wide enough and long enough that I can get both of these on here, so that's nice. So I don't have a lot of waste here. What I'm going to do is I'm going to spray some of this 3M Super 77 on the board, and then I'll just lay the paper on it. I'm not really looking for a firm and great bond. It only has to hold this paper on just long enough for me to get the edges cut out and the insides cut out, and then drill some of the registration holes, like a registration hole here, here, and here, and then the same place over here on this one. So once I get that done, I don't really care if the paper falls off or not. So let's get that done. I'm also going to wear a mask because I don't like breathing this stuff in. It's kind of nasty. Okay, so I got the template for the aluminum ribs to cut out their form done here. I have 3 registration holes that match up with the holes on the form. There's 3 here. So when I'm cutting out the ribs, and I'm going to use this aluminum to cut out the ribs, I'll drill registration holes in them also. So when I cut them out on here, they'll then go exactly in the right position when I put them on the form. I'm also going to use a router to cut these out. So I'll rough cut the aluminum ribs out of here. I'll lay them on this template, put the registrations hole in so they can't move around. I'll then cut some small holes here in these openings so I can then get the router down through those holes and route the inside edges, and then I'll also route the outside edges. I'll still have to do a little trimming on these corners. The router bit that I'm going to use is 3/8 of an inch radius, and these radiuses are much tighter than that, so I'll have to do a little bit of trimming, but that's okay. So here we go. Well, we got 2 of these done. And the reason I'm doing 2 of them is I want to do 2 tests. I'm going to do one test where I'm pulling up like we would be in the high G situation. And then I want to do another one where we're pulling negative Gs. Because we've got 2 different situations here. When we're pulling up like we are normally in flight, this will be in tension. And it should be really, really strong. And we're going to be pulling something like 3.8 Gs there. When we're like this, let's say we're flying upside down and we're pulling in this direction, that's going to be negative Gs. And in that case, this is going to be in compression and it's going to be pretty weak. And I want to make sure that this design can handle that 1.5 Gs negative. Also, I'll test one positive and I'll test the other one negative. Now I've weighed this, and one of the things I want to do was hopefully make it a bit lighter than the cantilever, but I realized as I was designing it probably wasn't going to be. Now I've weighed this and it's 70.6 grams. The cantilever version was 72.5 grams, so this is only 2 grams heavier. But I increased the gross weight of the airplane from 517 pounds to 580 pounds. So I need a stronger rib. Now, at 580 pounds gross weight, each rib would go from needing about 76 pounds per rib up to around, somewhere in the mid-90s, something like that. So this probably would have failed at the 3.8 Gs plus the 1.5 safety factor. This one was already deformed and it probably would have gone ahead and failed. So it could be that this rib is going to be optimal. We'll find out. We still have to form it, and that's what I'm going to do with this once I have finished with it. I still need to cut out all these inside pieces. Now this is going to be only 1/2 inch wide in these areas, so I'm going to glue this down to a bigger board to help hold these in place when I'm doing the forming. Otherwise, these could easily get broken. Another thing I want to mention, if you're going to use a router to route aluminum, you have to use safety glasses. This router will stick out a whole bunch of these little chips, and they come flying out of there really fast, pretty high speed, and they're hot when they come out. So I'd also recommend a long sleeve shirt, unless you don't mind getting pelted with hot pieces of metal. Well guys, that's it for this video. The next video, I'll finish cutting out the forming rib, gluing it down to some boards to support it. I'm going to go ahead and record my first feeble attempts at doing hydroforming. I haven't ever done it before. I don't know how well it's going to work, but we'll see what happens. If it's a complete failure and I have to end up doing the forming by hand, I probably won't show that. It's not very interesting. But the video after that will be testing. So I'll talk about that video at the end of the next video. Thanks for watching. Till next time.